Continuing with our geometric series, today with 9.3b. We are going to be talking about the sum of the geometric series. So here are two formulas that you're going to need to write down or know. So the sum of a finite geometric series. So there's a definite ending. So a finite geometric series is a sub 1 times 1 minus r sub n. Divide that by 1 minus r. However, if the geometric series goes on to infinity, then we have just a sub 1 divided by 1 minus r. Okay, let's use this in practice. So let's say we have a given formula. Let's scroll this down a little bit. Say we have n equals 1. We got 4 to the n minus 1 power all the way to 7. So here, first things first, we gotta find some things, right? Let's not make it 4. Let's make it a little bit more difficult. Let's say that's negative 4. We need to first find a sub 1, and to do that, we just put in 1 because we start at 1, n equals 1. So a sub 1 will be n equals 1. So that is 1 minus 1. Well, anything to a 0 power is 1. So that is a sub 1 equals 1. If you don't understand, we have negative 4 to the 0 power. Anything to a 0 power is 1. Now we have that. Our r value is our change, or the number that we're multiplying with each time, and in this case it is negative 4. So r equals negative 4. We have, and our n value is the very last number that we need to end at, which is up here. So our n equals 7. So I'm gonna I found everything, so now I'm just going to plug this into my formula. S of n equals a sub 1, which is 1 times 1 minus negative 4 to the 7th power divided by 1 minus negative 4. I'm going to simplify this a bit more. I get here negative 4 to the 7th power is negative 16,384. So this is 1 minus negative 16,384 divided by 1 minus negative 4. That's the same thing as saying 1 plus 4. Simplify that some more. This should be then 16385, yeah, because we're just adding 1 to that, and divided by 5, and our answer should be 16385. Divide that by 5, 3,277. So our total, our partial sum from n equals 1 to 7 is 3,277. Let's do another example out here. So let's say let's give another example. N starts at 0, goes up to 5, and we have 200 times 1.05 to the n power. Well, same rules, except the one thing we also kind of have to remember that here, since we started at 0, here our n is not going to be just 5, because since we started at 0, we have to take into account that we started at 0. So my n, instead of going to be 5, it's going to be 6, because I need to include 0 as an additional integer. Just a quick reminder of the formula that we're using. S of n equals a sub 1 times 1 minus r sub n divided by 1 minus r. So now we just got to find r. R is the value that's in the parentheses. Always is the value that's being taken to the exponent. So r is 1.05. A sub 1. So we just got to plug in a sub 1. We start off with n equals 0. So 200 times 1.05 to the 0 power. Anything to the 0 power makes that 1. So 200 times 1 is 200. Let's go on to solve this. So we have S of n equals 200 times 1 minus 1.05 to the 6th power, and 1 minus 1 point divided by 0.5. Let's simplify this some more. 1.05 to the 6th power is times 1 minus that. 1 minus that as our answer. Times that by 200. Divided by negative 0.05. Plug that into our calculator and I get 1,360 point, and they want 3 decimal places, so 383. So that is our answer with that geometric sequence. Now let's do some geometric sequences that go on to infinity. Just a little bit of reminder, that is a sub 1 divided by s infinity equals a sub 1 divided by 1 minus r. So let's say we have here n equals 0 to infinity, and we have negative 1/5 to the n power here. So now we just gotta find our units and plug them in. So we say a sub 1 must equal, well, n equals 0, so we start with 0. Well, anything to a 0 power, that's a 1. And our r value is negative 1/5, so we have everything we need. So s to infinity, the sum to infinity is 1 divided by 1 minus negative 1/5. Plug that into our calculator. 1 divided by 1 minus negative 1 divided by, and I got 5/6. Or if you want to work this out, this is 1 divided by 1 plus 1/5, which is the same thing as saying 1 divided by 5/5 plus 1/5 would make that, 5/5 plus 1/5. That would make that 1 divided by 6/5, which is the same thing as saying 5/6, and that's how you would do that. Another quick thing within the assignment, when it says use the summation notation to write the sum. So let's say they gave us 0.2 plus 0.8 plus 3.2 plus dot 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 plus 204.8. They don't actually want us to find the sum or write the sum. They just want us to write out the geometric series. So the geometric series, once again, we need to find a sub 1. If I remember this is a r dot 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 times so it's a plus a sub r plus a r squared dot dot dot. Well, they just want us to write that. They just want us to find the r. They want us to write it in the summation notation. So here, my r to get from 0.2 to 0.8, you need to multiply by 4. And my very first value, right, my ace of 1 is 0.2. And let's say we have here, so then if n equals 1, then I have 0.2 be my first one, my r being my r being, let's see here, 4. And now we have to keep in mind we want our very first one to be 0.2, so we want this 4 to actually go to the 0 power. So instead of keeping n, right, because then that would make our second unit, I want n minus 1. That will guarantee I'll have a n 4 to the 0 power, and I'll have a 0.2 as my very first term. Now I need to see what the very last term is to get 204.8. So I just plug this in and try to solve this here. So 0.2 times 4 times n minus 1 should equals 204.8 here on the side. Divide both sides by 0.2. So 204.8 divided by 0.2. This gives me 1,242. And I have a feeling that this is a power of 4. So if I take 4 to some powers, let me try it out. 4 to the 4th power is not enough. 4 to the 5th power does it. So 4 to the 5th power gives me 1,024. So n minus 1 must equal 5, and then must equal 6. So up here, I get a 6, and my answer like so. I want to talk about one last concept about an infinite series, and whether or not we can determine if there is a finite or a non-finite. With a finite series, we can definitely tell you an answer, but we can't always tell you an answer in a infinite series. Okay, so here is the parameters. If my r value happens to be a fraction, if it happens to be a fraction between -1 and 1, then logically we are going towards a value. Just think about when we have an exponential graph, and we know when there's an exponential decay and it's going down, 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 it's heading towards number, but it's never completely hitting that number, then we can say it's heading towards that, and it must be that sum if we head towards it into perpetually infinity. However, if we have the opposite way, where let's say we have a growth, right? We have an infinite growth. How do we find the sum of an infinite growth? Here, we can find it because it's heading towards a certain number. But when something is grown and it's out of bounds and it's so big, it's going to grow, grow, grow up until infinity. Well, we can't really measure that infinity. We can't put a definite number onto that. So in that case, this would be undefined, right? If we are going to be dealing with an r value into infinity that is not a fraction. So for example, if I got 1/16, -1/4, plus 1 minus 4 plus dot 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 dot, I noticed that the number is getting bigger. My ace of 1 is 1/16, but then my r value to get -1/4, well, I need to multiply that by -4. And here with this value of -4, I don't know how big this number is going to get. So in this case, we have an undefined.